will tell you when we should write things into our flipbook. 3.6. Thank you. All right, so a compound inequality is made up of two inequalities and we hook them together, we join them with and or. So we talk about and inequalities and or inequalities. So as an example, we might talk about all numbers greater than -7 and less than 6. This is a compound inequality. Now, if I were to graph this, there would be my number line, -7 and 6. For an and inequality, we're talking about where the two overlap. So greater than 7, going to have an open dot because it's not equal. So the numbers that are bigger than 7, and they have to be less than 6. So there's a 6, has to be less than 6. Well, those overlap here. Greater than 7 and less than 6. The other way we could think of this is between -7 and 6. And between kind of mean the same thing when we're talking about inequalities. And sometimes we think of this as a barbell inequality, because this looks kind of like a barbell. But I think if it's going to be a barbell, these circles should be a little bigger. Like that. Then it would look like a barbell, because you want some heavy weight on the barbell there. And this is made up of two inequalities. X is greater than -7 and x is less than 6. And we can hook these together in kind of a fancy way. We can say -7, I'm going to turn this one around, -7 less than x. So I'm flipping that one over like we've done before. And x is less than 6. So the fancy way that we hook them together is we say -7 less than x less than 6. So we string them all together. And all three of these mean the same thing. X is greater than -7 and x is less than 6 means the same thing as this. -7 is less than x, less than 6. X is between -7 and 6. Here is x between -7 and 6. All right, we're good there. An OR inequality. Sounds just like it is. All numbers less than -7 or greater than I'm going to say or equal to 6. So we have the or there. For an or inequality, what we're saying is that it's both are true. So I'm going to draw a picture here. X is less than 7. Number is less than -7. So again, I have an open dot on -7. But this time my arrow goes to the left, the numbers that are smaller than -7. And there's 6. It says greater than or equal to. So we have a closed dot there. But now we're talking about the numbers that are bigger than 6. Greater than or equal to. So this time for or inequalities, we have arrows pointing in the opposite direction. So sometimes we think of these as the thumbs. Because our inequality looks like two thumbs pointing opposite directions. And the solution is all of this, all of the numbers that are less than -7, or all the numbers that are bigger than 6. So it's both parts together. It's not an overlap, it's both parts together. And this is made up of two inequalities. X is less than -7, or X greater than or equal to 6. And we don't have a fancy way of joining the or inequalities together. We literally just write the word or. So that's what we mean by an and an or inequality. Mostly what we're going to be interested in is solving these things. So solving them, meaning we want to get x by itself, the variable by itself, we're going to make two inequalities and solve both. So compound inequalities involve two problems instead of one. So what I want to do is I'm going to put up an example of an and inequality and an or inequality solving. These examples are what should go under your flap, your third flap in your flip book. So for an and inequality, the solution is shared by both. And we can, with the way we think of that, kind of the everyday way we think of that, is where they overlap. And we're going to break this into two inequalities and solve both. So my example of an and inequality. -2 less than x plus 2 less than or equal to 5. So I'm going to break it into two pieces. The first part is I'm going to think about taking this and ignoring it. So the first inequality is -2 less than x plus 2. And for the second inequality, I'm thinking of taking this part and ignoring that. So the second inequality is x plus 2 less than or equal to 5. The other way we can think of this is, I'm going to circle this part in red. So we have the red part, that's here. And then I'm going to circle this part in blue. We have the blue part here. So I break that into two pieces. And I'm going to solve each one. So I want to get the x by itself here. So I'm going to subtract 2 from both sides. Those go away. Negative 2 minus 2 is 0. Less than x. Because these go away also. No, did I mess up? I did mess up. Let me get rid of some stuff here. Negative 2 minus 2 is what? Negative 4. There we go. Less than x. These go away. Negative 4 is less than x. That's the solution to this one side. Now I'm going to solve the other part. Subtract 2 from both sides. Do my arithmetic correctly this time. Those go away and I get x less than or equal to 3. 5 minus 2 is 3. So my solution is negative 4 less than x and x less than or equal to 3. Oh, I messed up again, didn't I? Did I mess up? No. I didn't. Never mind. Well, now to graph this, I'm just going to turn this around. X greater than negative 4 and x less than 3. So I have x is between negative 4 and 3. That's one way we could think of this. And my graph is going to look like this. There's negative 4. There's 3. I'm going to have an open dot on negative 4 and a closed dot on 3. Open because it's not equal, closed because it is. And we're between negative 4 and 3. And the fancy way that we could write this is just join these two together. Negative 4 less than x less than or equal to 3. So to solve an and inequality, we break it into two pieces and just solve each piece. All right, we good with that example? For our or inequality, our solution is all of both parts. Here our solution is where the two overlap. We're between something. For an or inequality, it's all of both parts. So our example, 6x minus 1 less than or equal to negative 7, or 2x plus 1 greater than 5. I'm just going to solve each of these separately. So for this one, I'm going to add 1 to both sides to start. Those go away. 6x less than or equal to negative 7 plus 1 is negative 6. Divide by 6. Those cancel, and I get x less than or equal to negative 6 divided by 6 is negative 1. Or, solve this one. Subtract 1 from both sides. Those go away. I get 2x greater than 5 minus 1 is 4. Divide by 2. Those cancel, and I get x is greater than 4 divided by 2 is 2. So my solution is x is less than negative 1 or x is greater than 2. My graph, this is going to be the one that looks like two thumbs pointing in the opposite direction. Closed dot on negative 1 because it's equal. Open dot on 2 because it's not equal. And there's my graph. So for both kinds of inequalities, we break them into two pieces and solve each one individually. For the and inequality, we're looking for the overlap. For the or inequality, we're looking for all of both parts. All right. Questions? Okay. Homework, we're in section 3.6. This is page 204. There we go. I'll leave that up there for a minute. And we have 20 minutes. You could easily get this homework done. And not have homework on the weekend. Yes, I need to figure out what number it was. Yeah, you want to grab one from over there? Yeah, there's one over there.